In this chapter, we will learn how to price simple derivative products using Monte Carlo simulation. Before doing that, let's introduce some definitions. A derivative product is a financial instrument whose value depends on the price or the level of some other more fundamental entity known as the underlying. The underlying can be an asset, a financial index, or an interest rate. A financial option is a derivative product whose buyer acquires the right but not the obligation to perform a transaction that involves the underlying at some time in the future. The conditions under which the transaction will be completed are specified at the time that the option is written, T0. If the buyer chooses to exercise the right given by the option, the seller has the obligation to complete the transaction. The amount received by the buyer from the exercise of the option is its payoff. The fee paid by the buyer to acquire this right is called the premium of the option. The period during which this right is in force is called the life of the option. The time beyond which this right can no longer be exercised is called the maturity or expiration date of the option. The price of the option changes during the life of the option and is zero beyond maturity. The first derivative that we will consider is a European call option. A European call option is a contract that gives the right but not the obligation to buy a specified amount of the underlying asset at time T0 plus T, the maturity of the option, at a specified price K, known as a strike of the option. To price this product, we need to make a model of the future evolution of the underlying asset. In particular, we'll use the Black-Scholes model. In the Black-Scholes model, the price of the underlying at maturity is a function of x, a sample from a normal 0-1 distribution. It is equal to S0, the initial price of the asset, times the exponential of R, the risk-free interest rate, minus 1/2 sigma squared t, plus sigma, the volatility of the underlying asset, times the square root of t times x. Let's analyze the payoff of this option. There are two cases. If the price of the underlying asset at maturity is smaller than the strike, then it will not be worth exercising the right to buy the asset at price K, which is higher than the market price of the asset. Therefore, for this case, the payoff will be zero. If the price of the asset at maturity is larger than K, then we will exercise the right to buy the asset at price K and then immediately sell it at the market price ST, realizing a benefit ST minus K. As a function of the price of the underlying asset at maturity, the payoff is equal to the maximum between ST minus K and 0. The price of a European call option will be a function of S0, the initial price of the underlying asset, K, the strike, R, the risk-free interest rate, T, the time to maturity, and sigma, the volatility of the underlying asset. It is equal to the discount factor times the expected value of the payoff evaluated at the price of the asset at maturity. For the European call option, there is a explicit pricing formula in terms of the normal distribution. In particular, the price of this option is equal to S0 times the norm CDF evaluated at D plus minus the strike times the discount factor times the norm CDF evaluated at D minus. D plus minus is equal to 1 over sigma square root of t times the logarithm of S0 over k times e to the minus rt plus minus 1/2 sigma square root of t.